everyone. My name is David Pedreira. I'm going to talk to you today how we build development environments for our developers at Mesa. By night I'm a contributor to the LXC project, and by day I work at Mesa. Mesa runs a platform for auctioning in the Netherlands called Vakantieveilingen, and more recently we have been expanding to Belgium and France as So when did we choose LXC? First of all, we run everything on bare metal, so we need to have an hypervisor in order to be able to run more than one operating system on the server. We are already running LXC as our main hypervisor for our production environment, and I want also to make a question to all of you: who is using LXC at the moment? And who is using LXC on their production environment at the moment? Okay, there's a few. All right. So we're already doing it for quite some time, for at least 2 years, and we are quite happy with it. So we want to keep it to also use it in the rest of our environment. Most of the services that support our main application, they were already running on LXC. They were being built with Puppet. So that means that we have an easy way to do all the reproducibility, and in order to build up the application part that we need. So for us it was just a natural choice to go with LXC. We are currently in the phase of migrating some of the bare metal applications into containers, and we want also at the same time to revamp our whole development, test, acceptation and production environment. We had some issues with our old development environment. We had a single server used by 30 developers, which is, it made me cry sometimes. We didn't have much flexibility if we wanted to install software, or if we wanted to upgrade something, or if a developer would come to us, hey, I would like to test this new MongoDB feature, blah, blah, blah. Or we want to upgrade our PHP version because it's going to be more performant. That's not going to happen as easy as you want, because we can upgrade our current development environments, and we don't really want to have to go through that trouble. Having a shared environment also means that if we want to run an application per developer, so that he wants to do these things, we need to map the applications to the developer, which means that if you want to have a memcache, for example, we would have to say, oh, we want a memcache, okay, this is your port, and then we need to make a mapping, okay, so this memcache belongs to this developer. That brings a little bit of trouble for us as well. One other funny thing is that we had to do a daemon restart every night, so that we just pick up all the memory and all the resources that were allocated to the daemons. So it's not very fun stuff. On our testing environments, we had fixed resources for our testers, so we had to build up a couple of virtual machines and some bare metal servers for them in order to test, so they would just redeploy the application itself. So we had to be a bit too careful with these environments, meaning that we would not touch them too much as well. If one of them was down, it was a bit of a problem, even though it was a testing environment. We had no proper way of cleaning up the environment on deploys. Reinstalled the packages, verified if our build system was working fine. And testers actually had to use a scheduling system to use up resources because they were limited. So some testers wanted to use a server that was more powerful for some stuff, and sometimes they would fight with each other, saying, "Oh no, I need it! Oh no, I need it!" So we want to end up with all of this. So enough talking about problems, and now I'm going to go a bit more into how we solve these issues. So how did we start it? We started by working on our Puppet recipes, and we started by building up a container which contains the application itself and all of the supporting applications for our main application. So We have our website, and our website requires an Memcache, requires RabbitMQ, requires all of those daemons working, and we started to do the heavy lifting on having all of those daemons running inside of a single container. That's one of the good things about the Linux containers, is that they are system containers, so you are running whole OS inside of a really tiny file system and a really tiny overhead compared to a virtual machine, for example. So that makes us that was really good for us, because we were already using things in production, and we just had to basically adapt what we had in production to run everything inside of a single container. At the same time, we also built our base image. Our base image had already all the software installed, so it already has the necessary software that it needed to run, and every time we booted that image, or every time we started that image, we would just run our Puppet apply, which would apply all the configuration stuff that we required, all of the things around it, and we would have a working application in about 2 minutes or something. Just to start up the container, run all the configuration stuff, and the image would be built and ready to be used. This was also the phase where we started the automation. So we built up the container automatically with a bash script. What the bash script does is pretty simple. Just launches the container based on the image that we have previously built and that we have previously done. Pulls our Puppet repository to inside of that container image. Applies all the settings that we need to apply, cleans up all the unnecessary files like log files, key files, history files that are not really required inside of the container. After that, it adds the container IP address to DNS, so that we can just type container name and we can connect to it. So at this phase, we already had a way to boot up a container, connect to it, and run the application. So this phase we were also talking to the developers to try it out, to figure out what kind of things were wrong with the container. But we run into another problem, and that problem is the fact that LXD currently, it's being developed, currently it only runs locally. So that means that if you have a bunch of LXD servers, you can remote connect to them, but they don't have a way to connect with each other, in the sense that they don't know, like, you are running X containers, I'm running X containers, and they are not basically aware of each other. So we decided to do our own orchestration tool. It's a very basic orchestration tool in order to treat the LXD servers as a cluster. We wrote our own orchestration script based on PyLXD. We call it the Mesa Container Orchestrator, or ECHO. And what it basically does is, you put all the LXD servers that you have on your configuration file, and then it will just put all of those values in a dictionary, and the key will be the name of the server, and the value will be the connector objects that you can use to connect to LXD. And how we are doing it right now, we just via the CLI, we say launch container, and it will figure out which of the LXD servers has the least amount of containers running. It will just launch the container there. It will retrieve any information related to the container, like IP address, name, any kind of what kind of storage is attached to it, all those kind of things. And you can easily add as well custom facts to the container. So that means that when you deploy an application, you want to know who deployed that application, or that container in this case. You want to know as well when was the container launched. And we also have added things like, someone deployed the master branch in here, or whatever branch, and some other stuff that you can add if you want. So at this point, we already have a way to launch everything, build up the container, and run the application inside of a single container, but we needed to have a way for our developers to launch it and without providing them any root access or to provide them any sort of access to our infrastructure. So we decided to use Jenkins for that. Jenkins kind of works like a front end for our shell scripts, actually. So when you click on the job to launch a container, it already pre-fills a lot of data. So it pre-fills your developer username, your public key that you want to use, the hostname prefix, so that you can give your container a name, and then you can connect to it via DNS. It will add a few records, something like container.developments.ms.whatever. It will also allow you to select a specific branch of your application that you want to pull, so in case the developer wants to test their branch or a tester needs to test the branch from a developer, it will be put automatically inside of the branch, and it will pull that code. So this is a bit of an overview on how the thing is working. So the developer goes first to Jenkins, launches the container. Jenkins calls the bash script, which is kind of a wrapper script. And that wrapper script will call echo. Echo will figure out, hey, where can I launch a container? Which of the servers has these containers running? Where can I launch it? It will launch it and it will say, okay, I launch a container on this LXD server. The next step is that because LXD still is kind of a local, we need to connect to that LXD instance. We run our provisioning scripts inside of the container. So as I've shown before, the puppet apply to do all those changes. After that is done, and hopefully success, it will add all of our DNS stuff into our DNS. Was it worth it? Yes, definitely. We fixed all the issues that we had for our development environment. So the developers now have root. They can play around with whatever software they want. Hopefully they will not try to steal with Spectre or Meltdown. Yeah, so we now have a better way to isolate and constrain resources if needed. So if they start to misbehave, they start to do some weird things with their application, we can easily burst down the network usage or the CPU usage, things that we could not do before with the single environment. We have now more of a dynamic environment for testing as well, so they don't need to schedule the resources or the servers or whatever. And so they can just launch containers and delete containers as they want. Yeah, the development containers are directly accessible on the network. This means that the container will boot up, it will receive an IP address, and they can connect to it and they can run whatever services that they want to connect directly from their laptop. And one very good use case for this that we are already using right now is that we run the unit tests. So when there is a merge from one of the branches, one of the development branches into our master branch, every time that happens, we just launch a container. We run all of our unit tests inside of that container because that container is great for that because it has all the application necessary, so we can run all the unit tests inside of that single container. And yeah, it's being done automatically. So container is launched, unit tests, deleted, bam, it's done. So now I want to show a bit of a demo. Just I'm going to demo the echo part. So I'm just going to show 3 LXD servers. So they are virtual machines running on my laptop, and I'm going to show the Python script basically. three virtual machines running, LXC01, LXC02, and LXC03. And these are just regular Ubuntu 16.04 running LXD on it. So now on the cluster there are 3 containers running. There's C1, there's C3, and there is C2. Okay, so now I'm going to create a container. Let's call it FOSDEM, based on Ubuntu. So now it is, so what the script is right now, it queries all of the 3 servers, it figures out that LXD03 is the one that has the least containers running, or it gave just a random one, because I guess if you have 3 containers, it will just give a random one out of it. So now it's probably pulling the latest image, might take a bit, it won't take much time. Yeah, so the container now is started, and it is on LXD03. So I can now go to LXD03. So now we see that the FOSDEM 2018 container is running there. It has IP address, IPv6, all the fancy stuff running on it. And you can also show some information about it. So this just returns the LXD host where the container is running, in case you need to connect to the LXD and to the container and do things locally. This is our custom facts that we add to the containers. So you see the container type usually is development, testing, or production. Created by the person who created the container, created at is the created date, the host name, IP, and brand. Currently everything is bogus because the Jenkins, we are not running this through Jenkins, and I'm not running this through the bash provisioning script. So it's showing just the bogus data because there's nothing currently there. And yeah, well, it started from the beginning. And that's it. Any questions? No, we are not using that. Oh, sorry. So the question is if we are running live migration for our developers. No, because currently there is no need for that. If a host goes down, we can just recreate the container and it will have everything that it needs in order to run the application. Any other question? Sorry, can you repeat the question? No, we have not considered. So the question is if we have considered using other technologies than the Jenkins or LXD. No, because this is what we were already running. So it's worked for us. We are quite happy with it. So we have not considered anything else for the time being. Any other questions? Yes.
Are you using
Jenkins too? So the question is if we are using Jenkins to delete the containers. Yes, we have a job to delete the containers with Jenkins. So that's a very good question. I should have put as well on the slides. We have a job or a website that shows currently the containers running inside of our infrastructure. And so the container name, host name, the developer like the shown there. And then they can just click a button, delete, and then the container will be deleted. And this is our. Excuse me. Sorry. It's our own plugin to Jenkins. Yeah, it's just basically is calling a shell script with a few parameters, and the shell script will take care of deleting the container and deleting DNS names and all that stuff. Yeah.
Thank you.
Yes, thank you.